Hello guys, welcome back to my channel, and today what we will do, we will talk about some tricky problems about the island of knights and knaves. Uh, yeah, these type of puzzles, and these are solved using the propositional logic concept of discrete mathematics. Okay, so let's begin. And yeah, this section will involve knights and knaves puzzles, where we meet different inhabitants of the mythical island of knights and knaves, and each inhabitant of this island, they are either a knight or a knave, and knights always tell the truth and knaves, they always lie. Okay, so we will see four problems about these, identifying these people are knights or knaves, and how to use propositional logic to come to the conclusion. Okay, so I will open our writing board. Okay, we'll take a clip of the question. Okay, so I will put the link of these, where I have taken these questions from, in the description box below. You can go click on that and you can go to this website to see the questions yourself. Okay, first question, we will take a snip of this first question. Okay, no problem. We will see from here only. So, can any inhabitant of the island of knights and knaves say that I am a knave? Is this even possible? Okay, so let's see how to solve this. What happened? Yeah. So we'll go to the writing board. So can even anyone who stays on that island, is it even possible that he will say I am a knave? Okay. So let us take, there are two possible cases for any person on this island. There are two possible cases. Okay, either he is a knight or he is a knave. Let the knight variable, let us say that knight variable is represented by 1, and if anyone is a knave, then its variable value will be 0. So let us take a person as P. So P, he can have only two values, either 0, that is he is a knave, or 1, that he is a knight. So we will check all the possible cases and see if that statement is true or not. First, let us say we will go to the positive, that P, any person P on that island is a knight. That means he always say truth. Okay, and what he is saying, he is saying that I am a knave. I am a knave, that means I lie. He is saying I lie. Now we have assumed that that person is a knight. If he is a knight, what he says is true. That means this statement should be true. Let us see if it creates a contradiction or not. And he is saying that I am a knave. That means he is saying that I am 0, or I am a knave, I am a liar, I say lies. Then can this statement be true that I am a knave? No. So this creates a contradiction. That means that, let us write this statement with the variable f. Okay, so we'll go to the board. So this if statement, if P is a knight, then this f statement should be true, but there comes a contradiction, right? Contradiction, which says that P should be 0, but we know that P is 1. Okay, so let us check another case. Okay, can P be 0? That can P be a liar? Okay, okay, so if that person is a liar, okay, he's lying, then what we can say? That whatever he's saying, it's a lie, right? So he's saying I am a knave, so this is a lie. This is false or 0. Okay, I'm representing false as 0. He's saying I am a knave and this is a lie. That means he has to be a knight. He has to be a knight because it's a lie. It has to be a knight. So, but we know, we assume that P is a knave. So this is also creating a contradiction. So this also cannot happen. That means, what does it mean? Nobody on the island can say, any inhabitant on the island, either a knight or a knave, can say, I am a knave. So let's check the solution. Yes, it also says, a knight couldn't make that statement as knights always tell the truth, and a knave couldn't make that statement either, since it would be true and knaves always lie. So nobody can say I am a knave on that island. So we will move on to the next question. Okay. These are not very easy problems, so I would recommend pause the video and think about it yourself. Okay. Okay, another second question is, you see two inhabitants of the island of knights and knaves, Ava and Bob. Okay. So what does Ava and Bob say? We will write it down on the board. Okay. Ava says that Bob is a knave, and Bob says neither Ava nor I are knaves. So what are Ava and Bob? Knights or knaves? Okay. So let us go to the board. We'll take the question with us. Okay. We'll erase everything. And then okay. So we will take statement P. Statement P represents that Ava is a knight. This is the statement. And Q would represent Bob is a knight. Okay. These are two statements. Okay. And what could P and Q can take as possible values? Right. All possible values, P, Q. P could be 0, 0. 0, 0 means both. This statement is false. That means Ava is a knave and Bob is also a knave. 0, 1, 1, 0, 1, 1. So in these type of questions, what we have to do, we have to substitute for the statements P and Q all possible values it can take and check whether, if we take these possible, one of these possible value cases, then what it is, whatever is given in the question, it creates a contradiction or is it can be a possible value. That's the trick of these type of questions. Okay. So what does Ava say? Ava say that Bob is a name. In terms of propositional logic, we will try to convert what Ava says. Ava says that Bob is a name. That means Q bar, Ava says Q bar. And what does Bob say? Neither Ava nor I are names. Okay. So Bob is saying, okay, neither Eva or I are names. So Q bar or P bar, the bar of this. So this is nothing but P and Q. If you simplify it using De Morgan's law, it will come as P and Q. Okay. That means it says both Eva and Bob are knights. Okay. So let us see what possible values can Eva and Bob be given. Okay. Which does not create a contradiction. Okay. Let us choose that both are knights. Both Eva and Bob are knights. If Eva is a knight, then whatever she says is true, right? Whatever she says is true. That means Q bar has to be true. And Q bar means Bob is a knave, and that is true. But we know we are substituted that Bob is a knight. So this case is creating a contradiction. So this cannot be the possible values for Ava and Bob. What about 0, 0? Let us check for 0, 0. Both Ava and Bob are knaves. That means whatever Ava says is a lie. That means Q bar is a lie, or Bob is a knave is a lie. Okay. So if this is a lie, that means Q has to be 1 or Bob has to be a knight. But we know that we substituted, right? We know that Bob is a knave. So this cannot be the possible value for Ava and Bob. Now we have two remaining options. Okay, let us check one of them. We will check this option first. Can Ava be a knave and Bob be a knight? Okay, so let us check. If Ava is a knave, that means she lies. That means Q bar is a lie, or Q bar means Bob is a knave, is a lie. That means Bob is a knight. So Bob is a knight, and we also assume that Bob is a knight. Okay, so no contradiction over here. Okay, what about this? Whatever Bob says. Now Bob is a knight, so P and Q has to be true, right? But we know that P is 0 or P is a knave, right? Eva is a knave. So this statement, what Bob says, becomes false. That creates a contradiction. So 0, 1 cannot be a possible value for Bob and Eva. Okay. So the only option that is remaining is assignment that is remaining is Eva is a knight and Bob is a knave. Let us check this option creates a contradiction or not. It will not, but we will still check it. So we know that we are substituting P, that means Ava, as a knight. So whatever she says has to be true. So Q bar is true. That means Bob is a knave is true. Bob is a knave. That means Bob lies. So P and Q has to be false. If P and Q has to be false, and we know that Q is false, right? Bob is a name. So it does not create a contradiction. It is valid according to what they are saying. So this is the right option. So for this question, the answer is that Ava is knight and Bob is name. That is the correct answer. Okay. Let us move on to the next question. We will check the answer with this. Final answer is Eva is knight and Bob is a knave. So that's correct. Okay. All right. So next, let us go to the next question. Yeah. Go to the next question. Okay. Example 3. So, yeah. What is the question? Between Eve and Fred. Okay. We will bring that in our writing board. New page. Okay. So you have two different inhabitants, Eve and Fred. Okay. What Eve says is, I am a knave or Fred is a knight. So who are Eve and Fred? Knights or knaves? Here also we will take all possible cases. So the statement S represents that Eve is a knight and T represents that Fred is a knight. So what possible values can S and T we can give? All possible cases. Both are knaves. 0, 1, 1, 0, 1, 1. And 1 represents true, that this statement Eve is a knight is true. It can be either true or false. It is representing all possible cases. We can assume that Fred, that this statement can take. Okay. Now Eve says what? Eve says, we will convert it into compound statement, right? Eve says, what does she say? I am a knave. I am a knave means it's Eve, right? That is S bar, or Fred is a knight. Fred is a knight, or that means T is true. Okay. So let's see. Let us first take the value when S is both are 0. Can this be a possible assignment? Does it create any contradiction with what Eve says? So we are taking S is 0. That means Eve is a knave. Eve lies. So whatever she says should be a lie. Okay. So S is lying. Okay. S is lying. Okay. S is lying. That means what will come out from here? Okay. S bar, right? S is lying. So what we'll get? S and T bar. We are applying the bar of whole this thing, not of whole this thing. S and T bar, right? That means what what is the true? Should be that Eve is a knight. This has to be true, and T bar, that Fred is a knight, should be false. That means Fred should be a knave. Okay, but we know that this is creating a contradiction, right? To make this statement false, this should be true. That means Eve should be a knight and Fred should be a knave. But it is not the case we assume. So this is creating a contradiction. So 0 0 both are knaves is not a right answer. Okay, I'll erase this part. Okay, now that means that clearly concludes that. Now we will check the next option. Okay, I am assuming can Eve be a knave and Fred be a knight. Okay, so if Eve is a knave, then whatever she says has to be false. If this statement is false, okay, that means this statement should be a false. Okay, that means S dot T bar has to be true, right? That means Eve should be a knight and Fred should be a knave. But that is not true. That means this should be 1 and this should be 0, but that is not possible because uh, we we were checking the option of S being a knave. So this is creating a contradiction. So this option is also not a valid assignment. Okay. So these two options are remaining. We will check that. Okay. Okay. So what if we will check for this option? Can Eve be a knight and Fred be a knave? Okay. So if Eve is a knight, then whatever she's saying is true. Okay. Whatever she is saying is true. And what is she saying? That I am a knave. I am a knave. I am not a knight. I am a knave. And Fred is a knight. But this is wrong, right? We were checking that Eve is, we assume that Eve is a knight. So this is creating a contradiction. So this also is not a valid option. So both has to be knight. That can be the only assignment. Okay. So if both are knights, then she is saying true. And Eve is saying true. And if this is a true, so I am not a knight, I am a knave, or Fred is a knight. One of them is true. And I know that the Boolean outcome of this, because S is 1, so S bar is 0, S bar is 0, 0 or 1 is true. So what she's saying is true, right? Fred is a knight. When this statement will be true whenever Fred is a knight. So This is the only valid assignment, that both are knights. Okay, we'll check the answer. So yes, this is the answer. See that Eve and Fred both knights. Okay. Okay, last question. We go to the last question. Okay, so we'll bring the question on the writing board. Okay. So you have three habitants, Sarah, Bill, and May. Okay. Sarah tells you that only a knave would say that Bill is a knave. Bill claims that it's false that May is a knave. And May tells you Bill would tell you that I am a knave. So, who are Sarah, Bill, and May? Knaves, knights, knaves or knights. Okay. So here this have three variables, three possible substitution. That means three variables mean how many possible input combinations? 2 की power 3. 2 की power 3. 8 possible cases can be there, and that would be too tedious to check. So how can we check it in less time? Not checking all the 8 possible combinations. So first we will write the statements, identify the statements. Let P represent that Sarah is a knight. Okay. Q represents that Bill is a knight. And R represent that May is a knight. Okay. So we will convert whatever these three people are saying into a compound statement. Okay. So whatever Sarah says, what she says is only a knave. Knave means I will take its value as 0. Would say that Bill is a knave. Right? So this and this both has to be true. So this logical and will be connected, and Bill is a knave. Bill is a knave means Q bar. Q bar. Okay. So then what is Bill say? Bill say that it's false that May is a knave. So May is a knave means R bar, and not of that. That will make you only R. That Bill is a knight. And then what is May saying? May is saying that Bill would tell you that I am a knave. Okay. Bill would tell you that I am a knave. Okay. So if it's a bill, that means Q, and I am a knave. That is May is a knave. R bar. Okay. So we have converted whatever they say into propositional statements. Okay. So we don't have to check all the possible input combinations. We will think what uh, the possible values could be. Okay. So let us say we can see that Sarah says 0 and Q bar, and we know that in a logical AND both inputs has to be true for this statement to be true. So this is always a false. That means whatever Sarah is saying is always a lie. So let us substitute Sarah as a knave. Knave means 0. Okay. Substitute Sarah as 0. Okay. So whatever she says is a false. That means, right? Okay. Then what about Bill and May? What do we substitute them? Right? We can check for Bill and May one by one. Okay. So I know that we have fixed a value for Sarah. Now, what about What about R? What about Bill? Let us substitute Bill as night. Initially, we will substitute Bill as night and May as also a night. Let's see, let's check for this case. Okay, because we have one less variable, now we have to check only 4 cases for Bill and May. Okay, so Bill is a night. That means he says the truth. So R has to be true, right? And that R, what does R is? May is a night. So May is a night, right? Yes, May is a night. That means whatever May says has to be true, and it is not contradicting from what we assume. May is a night. Okay. So Q Q is true. Q, what is Q? Bill is a night. Yes. And R bar has to be true. That is, May is a knave has to be true. Then only this statement would be true, but it is not. So it is creating a contradiction. So 1 cannot be an option. Okay. Then what text we can check? 0. Let us take Bill is lying. Okay. If Bill is a knave, then R has to be 0. That, what is R? That May is a night. That means May is a knave. Whatever she is saying is a false. Okay. But we assume that May is a night. So this cannot be a case. So we have to take May as 0. Okay. Let us check. This is, this can be true or not. Okay. Now we assume Bill is a knave. So whatever he says is false. So he says May is a night, right? May is a night, which is false. That means May is a knave. Okay. And that is not contradicting with our assumption. Now let's see whatever May is saying, it's also becoming false or not. Okay. So May is a R bar and Q both has to be true, right? But R bar has to be true, right? So R bar, when is R bar true? When R is 1, right? But R over here, that May is a night, its value is 0. That means, what does that mean? 0 bar. Oh, wait. It is R bar is true, but Q, our statement Q, that Bill is a knight, is false. So this statement becomes false. So 0, 0, 0, that all 3 are knaves is the correct option. Okay. Okay. Let's see. Yes, we conclude that all 3 are knaves. This is the right answer. Okay. These type of questions are not very easy to solve. They are tricky questions. So practice at home and happy learning. Bye bye.